Today's date is October 7, 2025. My time is 18:06 p.m. I am in the United States, Florida, Ormond Beach City. And I'm gonna try to do a session tonight to test the SvBONY MK105 on 3 different configurations. The first one is gonna be this configuration, the 0.5x focal reducer. I'm gonna add a light pollution filter to experiment. I'm gonna be in front of the house with a pole light and my United States flag light on, so I have a lot of light around, artificial light. So that's the reason I'm using this configuration. The second configuration, I'm gonna take off the 0.5x focal reducer. I will take it off, and I'm gonna just put the light pollution filter on it. And then the third configuration, I'm gonna use the 2.5x Barlow, Teleview Barlow, and I'm gonna still adding a light pollution filter also. That way I experiment in these 3 configurations. The targets are Saturn and the moon. Let's see what happened tonight. That way I'll give you a one picture of each configuration. After I finish this, if I got time, I'm gonna take my Nexstar 8SE and also use it with an SvBONY camera. Maybe the same thing, Moon and Saturn, provided I get time, only on this configuration, F10 configuration. I might add Teleview 2.5x Barlow. So that's the plan so far. Real quick, I will show you how I plan for this tonight session. Basically, I'm planning like an hour before. I knew it's gonna be kind of a clear, so I already got the mount and the telescope outside, so it can guess 2. So what I do, I'm gonna show you real quick. I got this program called Starry Night, and then about 8:05. Oh my God, I did something here. Let me see. 2, 1. There we go. Bye. Sunset is at 7:05, but I always add about 30 minutes after that, which is getting kind of a little bit dark. So I go in minutes. You see it's changing the minutes there to 7:34. Whoa. I'm having a conflict here in the software. There we go, 7:34. By 7:34, the moon is gonna be way low. It's gonna be about 14 degrees, that's too low. But Saturn is gonna be a little bit higher. Saturn. Saturn is gonna be about 28, that's still kind of low. So I'm gonna add an hour and see what happened. An hour ahead. 8:34. Saturn about 40 degrees, that's pretty good so far. Remember, the higher the better. And the moon is gonna be about 27 degrees, still low. But these are my targets. That way I got an idea when the planets or the moon is gonna look. So I'm gonna hit first to Saturn and take the 3 different takes on 3 different configurations on the MK105 Maksutov, so that way I can compare the pictures and show it to you. And then by the time I finish with Saturn, the moon is gonna be up, and then I take the moon. Remember, my conditions are kind of the worst possible. In front of my home, I have the United States flag in front of my home, the light on, and then the pole on too. So I'm gonna use the dew shield and light pollution filter and take it from there. Of course, I'm going to use the soft dew shield made by Astromania, because that's gonna help for the light pole pollution from the light pole and the US light flag, or from the US flag, the light pole from the US flag. I just installed the telescope into the mount. I'm using a Nexstar 8SE or 6SE wedge over here. and then I put the fork, the single arm fork, in it or on it, and I'm gonna finish the cabling and put my computer. But it's early. I'm just waiting for the equipment, especially the telescope, to stew. That way I acclimatize to the temperature. I'm gonna be shooting over there. Some cable interruptions, of course. That's the light. That's gonna be the light from the US flag, and that's the pole light right there. This spot is worse than the backyard, so I'm gonna do this test on purpose, and I'm still waiting. It's kind of windy too. You can see the wind, you can see the flag. So this is, so far, this is what it is. And here you can see to the left, the pole light, street pole, and my flag light, and that's the contamination I have while taking the objects tonight, Saturn and the moon. So you can take a look how it look like there. I'm still waiting for the objects to appear. If I'm not mistaken, I believe that's Saturn there, and I should give it a shot soon. So let's see. Hi, in this section I will show you a quick cliff notes on the process I did last night on Saturn. I wanna test the telescope, the Maksutov MK105, in 3 different configurations of focal ratios. The first focal ratio, or the first configuration, is using the focal reducer at 6.5, focal ratio 6.5, which I started about 8:10 last night, and then about 8:16 I changed the camera while I was running live. I changed the camera, I took the camera off, and I took off the focal reducer. I had the light pollution filter, by the way. I took the focal reducer off, I took the filter, light pollution filter, and put it back in, and I changed the focal ratio from 6.5 to the native f13, which was about 8:16 last night, about 6 minutes after the first focal ratio. And then about 8:30 last night, I changed it to I put the Barlow 2.5 Barlow teleview, and I changed the focal ratio to 32.5. So this is a quick view for you on the imaging software, so you see how it went. So I'm gonna minimize this, and right here, right there, you see I trying to look at the planet to focus as best as I could. Focal ratio 6.5 on the Maksutov. That's why I increase the zoom to get the better focus I can. Then let me see, once I focus, I went to auto, and that's the actual image there. That's the actual, that's how it looked like right there on that focal ratio 6.5. And the picture that I processed real quick, this was the result on the picture based on this. And I did a real quickie job there to show you. It is a very hard thing to do on that focal ratio, but I got another example. Let me pause this. I had another example using, let me see if I find it, using this focal ratio of f6.5. Let me find the proof here. This one here. Same focal ratio, same setup. Of course, I didn't have the filter at this time, but this is Jupiter. So it's all about lucky imaging too. Here you can see a very, very picture. Maybe because the planet is bigger than Saturn, I don't know, but it's basically local imaging or lucky imaging. Now, let's go back about last night. I changed from focal ratio f6.5, I took off the focal reducer and I converted focal ratio to the native focal ratio 13. And you can see when I start changing the camera, let me go fast forward this video. When I start taking the camera off, let me show you real quick. I'm fast forward this. Then this time I was capturing images too. There we go, right there. Let me see, go back. All right. Right there, I took the camera to get the focal reducer and the light pollution filter off the camera. I was twisting the camera. I was worried the cables are gonna be breaking or making something, but I just took the risk to show you what I did. So at this time I'm taking the camera. I took the focal reducer off, and I put the light filter. I put the light pollution filter to change the focal ratio from 6.5 to focal ratio 13. Focal ratio 13. And I'm still working there, struggling changing the camera. Let me see if I can fast forward this. There we go. That's the right there. Now I'm focusing on focal ratio 13. I'm focused manual focus. And then let me go a little bit fast forward here. There we go. Now it's automatic there. And that's the focal ratio 13. And this is the image I came up last night. It looks like the first one, but it's a little bit bigger. And of course, I'm using crop techniques. So it's gonna change the image size. Now, the next part is when I put the filter. The next part is when I use the 2.5 Barlow lens. Let me fast forward a video here. Right there you see is the focal ratio 13, and I'm capturing, I believe, or working on it using the ROI technique or region of interest. But let me go to when I change the focal ratio using the Barlow about 8:30 last night. There we go. Right there is when I take off the Barlow or the camera. Did the same. Working, struggling a little bit, worry a little bit because I don't like to do this, but I did it just for an experiment so you can see what I did anyway. Let me fast forward the video a little bit here so you see the 2.5 Barlow lens. There we go. Right there I found the planet on the Barlow, and you're gonna see when I start getting the planet in the middle, adjusting the focus. There we go. Right there you see 2.5 Barlow, and now I'm in the process to focus and clear the image too. I believe that's the best focus right there using an exposure high. You can see Saturn. You can see Saturn and a moon there too. There's a moon. And here I got the 2.5x Teleview Barlow lens. I just record that. And then I'm gonna leave it there so you see how it looks like when you focus using the Barlow. There we go. I'm reducing the exposure, as you see, so you can see the planet, getting better looking. Right there. There we go. You can see it there. And that's the best. And that's manual focus, by the way. So a combination of manual focus and changing the exposure and playing a little bit with the gain. And at the same time, you have to get the planet in the middle of the field of view so you can start capturing. Right there, I am capturing right there. Now, to show you the result on this one that I did this morning, that's the result. Not the best picture, but that's the result there. And let me see. There we go. This is Jupiter when I first started using the equipment at focal ratio native focal ratio 13 on the Maksutov MK105 SvBONY, and that's the demonstration there. In the meantime, last night when I started with Saturn, between 8:10 and 8:30, this is at 8:11. Let me go 8:10. At 8:10, you see that the altitude was 24 degrees, which is another, problem or another situation that the picture is not gonna get that well done. Maybe I needed to use maybe I should use an atmospheric dispenser or dispersion corrector. Atmospheric dispersion corrector. Maybe I should use it there, but I didn't have time to react. So at 8:10, the first demo, that's the altitude on Saturn. Then at 8:16, $25 degrees, not much of a difference. And then at 8:30, at 8:30, 28 degrees. So it's not a big difference on altitude. And in top of that, I have the moon, light pollution from the moon. And like I showed you before, I was in front of my home with the pole, light pole, street light pole, and the flag, my US flag, light in top of the pole. And that, it's a lot of light stray and light pollution, and it's very, it's not the best condition to take pictures of planetary. The moon is a little bit more forgiving. So in this section of the video, this is what I want to show you. Here, to review real quick what I did last night, you can see the first picture is focal ratio 6.5 on Saturn. Picture has been cropped, so sometimes the sizes, I increase the sizes. The second picture is focal ratio 13, and the third picture is focal ratio 32.5. In the first picture, I use a 0.5x reducer. The second picture is the native focal ratio of the Maksutov 105 telescope. And of course, I add a 2.5 Barlow lens, and you see the focal ratio 32.5. Remember, low-key imaging takes a big part on this. And I was working on a rush, and the planet was very low, the altitude, around 22 degrees or so. Now, I'm going to show you proof of past pictures using the same focal ratios. On this time, at this time, using the same succession of focal ratio with different planets in the past. So you see the difference of low-key imaging, that takes a big part of it. Right there. The first one is Mars, planet Mars. The focal ratio 6.5 using the 0.5 reducer. The second picture is Jupiter. Focal ratio 13. And the third picture is Venus. Focal ratio 32.5 using the 2.5 Barlow lens. As you see, Jupiter is kind of sharp. That's why it looks like kind of sharp, too much sharpness there. It's the same phenomenon on here, but not on the middle. Just when using the 2.5 Barlow, it looks like a lot of sharpness there too. So this is there's a lot of factors playing. And but at least I give you a nice demonstration. That was a picture I was looking for. So you have here what I did last night with Saturn, and you have here what I did in the past using the same 3 types of setups. I want to take this opportunity to thank Tsula. She has a channel called Tsula's Big Adventure, and thanks for her. I make this video. She gave me some good advice, and I appreciate it. Thank you, Tsula. I will appreciate if you subscribe in order for you to see more videos based on the content of your comments, and that way we can share information and learn from each other. I hope you enjoyed this saga I had last night on planet Saturn. I apologize I couldn't do the 8-inch telescope, and also I didn't show you the moon, even though I took a lot of data of the moon. But that's gonna be for another video anyway. You have an idea, 3 focal ratios using the MK105 Maksutov telescope on planets, and it works. The telescope works with the mount, of course. Thank you very much. I wish you clear skies, and I'll see you next time.